Hello and welcome. We're going to be talking today about the growth model that's used in Arkansas, and I am going to share my screen so that we can get started. Today we'll be talking about growth and student achievement, Arkansas's value-added student and school growth model. My name is Denise Arola. I am the director of the Office of Innovation for Education, and I have been working with Arkansas Department of Education, Division of Elementary and Secondary Education on assessment and accountability now for 17 years in various capacities, 8 years in my current role as the director of the Office of Innovation. And I am thrilled to talk about the growth model that we have here in Arkansas because it is unique, not used in many states, and has several advantages. So let's go ahead and get started. The guiding questions we'll use today are, what do we mean when we talk about growth? How does it work at the student level? How do we move from student level to school level growth scores for ESSA? And does this model still work in 2021 since we are missing 2020 scores? All important questions, so let's get started. I know growth seems intuitive. If you look at the pictures here and look at the definitions on the screen, you could get these just by Googling the word growth. Sometimes growth seems really obvious. The process of increasing in physical size, for example, it's really easy to view that with plants, with puppies, with kittens, with children. However, not all growth is obvious and intuitive. Growth is actually pretty complex, particularly if we start to talk about development, which could be in a variety of different ways. So if we think about human development, for example, some of the things that grow and develop within our little humans that start out as newborns and turn into infants and then toddlers and teenagers and preschoolers on up, some of the things that are happening in their brains and in their bodies are not obvious. They're under the surface. We can't visually observe what's going on inside, but then we have these signs that we look for, these measures that we use to try to interpret what's happening in development. Growth and achievement is similar to that more complex idea of growth. So, for example, if you think about physical development and gross motor development, our little infants go from being little blobs, as my husband used to call them, to having a strong enough neck to hold up their head. And then they get to the point where they can sit up and roll over and crawl and walk and run and jump. And it's a continuum that you can see, but what you can't see is what's going on inside the brain. Right. And we have all these growth and development charts that help us to kind of gauge whether or not our children are going through these stages of development as we expect them to, or within an expected range. So when we talk about achievement and growth and achievement, we need to be really clear and define it for the purposes that we're using it. So let's do that. Let's clarify what we mean by growth. And let's start first by talking about achievement. We have a measure of achievement. We have the ACT Aspire, and we also have the dynamic learning maps. In the case of our growth model, dynamic learning maps does not provide scores that we can use. So when we talk about our growth model, we're talking about the use of our achievement scores from the ACT Aspire. And measures of achievement are point in time, like these little dots on this chart on the right. And they evaluate how well a student is performing against a particular set of criteria or relative to some sort of standard. So if I'm an infant or toddler, I'm being compared to a height and weight chart. That's a relative set of information. In the case of achievement, we can look at achievement in a variety of different ways. ACT Aspire gives us how well a student is performing relative to college and career readiness. And so when we think about these points in time, that tells us where they are at that one moment. For growth or progress in achievement, we use the word growth in our model to describe a measure of change in achievement from one point in time to the other. So in the case of growth, what we're really interested in is describing those lines on the chart to the right. What's happening between this point in time and this point in time? That's the really important piece that we're interested in when we're talking about growth. And growth in academic achievement can be measured in a variety of ways, and different states use different models. And we were more limited in the early years of NCLB, but under ESSA, we can use models that have been under development for years that have incredible characteristics. They're super powerful, and they're complex, but they also do things that we need them to do. They do things that are different from our actual measure of achievement. They tell us how well students are changing from one point in time to another, and they do it differently. So if you want to read up on growth models, here are a couple of resources. And of course, this is a practitioner's guide, so it's written in language for educators. This is not a guide that's just things that are intuitive. This would be very short if that were the case. There are models of growth and achievement that are very intuitive, but unfortunately, those come with some really big disadvantages and some limitations that don't add to what we understand about how students are changing in achievement. In contrast, the model we use is less intuitive, but it certainly does answer questions that the more intuitive models can't answer. So here are some resources if you really want to dig deep and understand what we're talking about. But let me give you some details as we go, and hopefully this will help answer a lot of your questions. So the ESSA growth indicator uses a growth model that answers the question, how much did a student grow this year compared to how much we thought he or she would grow based on what we know about his or her achievement in prior years. We call their prior year's achievement their score history. And so that's what we're really talking about here. Now, technically, our model has been called a number of things because the language around these models is different in different research literature. So sometimes it's called a longitudinal growth model. That's one of the models that I think, that's one of the terms that is used a lot in education research. In other fields of research, these types of models might be called value-added models. And technically, it's in detail a multi-level residual gain model. Now, you don't need to remember that, but that particular description really captures what we're doing with the data and has the advantages we were looking for and what we were going to do with this growth model. And so take a look over here at the chart on the right. We're looking at a student's score history. So how have they been doing in the prior years leading up to this current school year? So we use up to 4 scores. I know in this chart it says prior years, 4 prior years, but because of COVID, we're going to be using up to 4 prior scores, which is true. This model is very, very robust. It operates really well with missing data. And so we will be using that to, and I'll be explaining that a little bit later on in the presentation. It's called value added because the score history itself, knowing where a student has been, their achievement story, helps control for factors, student level factors that schools and teachers don't have control over. So we do know that when kids come to us from poverty backgrounds or are in particular student groups, that oftentimes those have been associated in the past with lower achievement or with challenges in improving achievement. And so we want to control for that because the school doesn't have control over who comes to them. The school is working with the students who walk through the door. We want a model that controls for what the school can't control and then gives us information about how well students in the school did when we control for the factors that our teachers and leaders can't control at the local level. So let's take a look at that. Simply speaking, there's really these 2 steps that go on. What we do is we first use the score history to figure out what do we expect based on what we know from a student's past. And then we use their current score to figure out, did they land there? Okay, so the first step is, what do we expect from the student based on their achievement story in prior years, based on their achievement scores? Then we look at whether or not they met that expectation, exceeded it, or didn't meet it. So again, I'm just going to say this one more time because this is probably one of the hardest things. The score history of a student tells their achievement story. We use their achievement story, each individual student's achievement story, literally, to determine, to make the best estimation of where we think they'll be this current year. And then we look at, did they achieve that? So in the graphic in front of you, the score history is represented by these medium dark blue dots on the left. And then in grade 8, directly above grade 8, in this example, we have a light blue dot. If the student actually scored where they were expected along this line of best fit, then we would say they made expected growth. They would have a 0 score because there's no difference between what was expected and what occurred. If they made more than expected growth, they would be somewhere in this green dashed line and green dot because they would be above that expectation. And if they made less than expected growth, they would be below that expectation. So take just a minute and give yourself a second to just take in the information in the chart and make it understandable to you. Get it in your brain. Take just a moment. Okay. We're going to look at several examples because we have a very special model, this multi-level model, which is basically the levels are the student and their scores. So their score history, or their achievement story, as I've come to call it, is the first level. And we have scores that are nested within the student. The student is the second level. That's our object of interest. So let's take a deeper look. Our state summative assessment, the ACT Aspire, is designed with a vertical scale, quasi-vertical. This means that higher scores are associated, are interpreted as meaning higher achievement, and students are expected to increase their scores over time as they progress through the grade levels. Arkansas's model for growth uses this characteristic of the assessment. So this is just really important. In this chart, let's see what that means. You will see two students. You've got Ben and you've got Nick. And let's just start just through description and observation. We're going to do description before we talk about what it means, or analysis. So look at these kids. This is their actual score histories going through from grade 3 to grade 10. And let's just describe what we see. For Ben, we see a trajectory. We see achievement scores that start in the middle of the scale, the score scale on the left. And each year, Ben has slightly higher scores than the prior year, except for in grade 5, where Ben's score is almost the same as in grade 4. But each year, slightly higher achievement scores until grade 10. We can contrast that with Nick, who starts in grade 3 at the slightly lower end of the scale, the achievement scale, score scale, and has higher scores each year all the way through grade 7. And each year those scores are slightly higher. The lines are slightly steeper each year through grade 7 if you're looking at Nick compared to Ben. And then in grade 8, Nick has a lower score compared to grades 6 and 7. And then in grade 9 and 10, Nick is scoring higher than prior grades. So we're interested in our model in really understanding the lines between each of these points in time. And if I were to describe the lines, thinking about the slope of a line or the steepness of a line, I would say that Ben's lines are less steep than Nick's lines most of the time, except Nick actually has a declining line between grade 7 and grade 8. So take a moment and focus on Nick's lines, because we're going to use Nick as this example to show you how the model is working for a single student over time. Okay, take a look at Nick's history. This is the exact same history we saw on the prior slide. We can go back in time and we can simulate what the expected growth would be for Nick at different times in the score history. So this is an important little piece to pay attention to. Take a look at Nick in grades 3 through 6. This is the score history that we would be using for Nick to estimate what we would expect Nick's achievement score to be in grade 7. So if I start here, okay, so if I start here and I draw a line of best fit for Nick based on his first 4 scores in achievement, then you can see that this brown arrow would take me to what I would expect for Nick in grade 7. Now, this next chart is going to show you that in grade 7, Nick achieved at a higher score than in grade 6. And if you were to compare that brown arrow, the line of best fit for Nick and only Nick, then you would see that Nick met their expected growth, because Nick's actual score here in grade 7 is higher than where we would have expected him to be based on his achievement story in grades 3 through 6. So now let's look at grades 4 through 7 to figure out where we would expect Nick to be next. So take a moment, think about it. An important component of our model is that we only use the most recent 4 scores that we have available. So that means that each year that we calculate growth for a student, we're using just the most recent available score history we have for the student. This is going to be really important, you're going to see as we go on. Excuse me. This is a really important advantage of our model over a lot of other models. So look at where Nick would be expected to achieve in grade 8 based on his achievement story from grades 4 through 7. We can see that he's been progressing at a pretty steep rate each year. And so even though grade 7 is a little less steep than grade 6, we still expect his score to be higher in grade 8. But what we know from what we learned in the very first slide is that in grade 8, something happens and Nick's score is lower. We cannot say why. I cannot say why when I look at Nick's score history. Only the people who were locally involved in his education know why Nick's score was lower in grade 8 than in the prior years. That's important because when you look at students' estimated growth, what we think they're going to do and what they actually do at the local level is where you're able to really put some meaning to that. Now, we're now moving to grade 9 for Nick, and we're interested in whether or not Nick is going to meet expected growth in grade 9. Obviously, from the prior slide, he didn't meet expected growth in grade 8. But what do we expect now if we take into consideration the 4 most recent scores? In this case, it's grades 5 through 8, and we fit a line that is the best fit for those 4 score points. You can see that instead of the line continuing to go straight up at a steep rate, this grade 8 score has now moderated it. It's adjusted it down just a little bit. So my slope is a little less steep than what it was expected to be when we were looking at grade 8 expectations. So now in grade 9, we have an adjusted expectation because these are the 4 most recent years of, or scores of Nick's achievement story, score history. And if you remember, in grade 9, Nick did, in fact, achieve at a higher score than in grade 8, and likely was right on or just below expected growth based on this line of best fit. So then in grade 10, because of this adjustment, we continue to see this fitting. And so the point in these illustrations is that our model in Arkansas does a really good job of taking into account where students have been in their achievement history, their score history, and each student is estimated for their expected achievement in the current year based on their unique score history. And that's important. The model actually allows for the fact that kids start at different points, like Ben and Nick did, and that students actually progress at different rates, some faster, some slower, some increasing, some flat, some declining. So just to recap, let's all get on this same level for just a moment. So for a quick recap, at the student level, we calculate growth scores. We use a mixed model. You can get more details about the model in the final ESSA plan in Appendix D on page 162. It's a mixed model because we use score histories that are nested or clustered within the student. This is an advantage of our model because it treats each student uniquely to their history, their achievement story. We use the expected score and the residual, which are both produced by the mixed model. And the residual, which is the difference between what we expected and what the student actually achieved, that becomes the student growth score. So the observed score, their current school year score, minus their expected score that's built from their score history, their achievement story, gives us their growth score. If it's a 0 or above, then that means they met or exceeded expected growth. If it's below 0, then that means they made less than what we expected in the way of growth and achievement. This is important. The magnitude, the difference, the further they are from 0 in either direction, the more or less growth and achievement was made. So if you have students who are at a 1, that's 1 standard deviation above what was expected. That's huge. That's a pretty good effect size for a student in a single year. And if you have 1 standard deviation below, that's a cause for concern. That's where you want to go in and like in the case of Nick and his 8th grade score, we'd want to know more about what happened there. Was that a fluke? Did Nick have a difficult year? Was Nick in and out of school? What was going on in Nick's life that his achievement score was lower than 0, or excuse me, his growth score was lower than 0 from 7th to 8th grade? So these scores can really make a difference in helping you to understand where students have been, what we expect of them, and whether or not they're growing in achievement to meet expectation. Now, there's been some confusion, particularly since we haven't calculated the model in 2 years, about who gets a growth score. So growth scores are calculated for grades 3 through 10 students in math and ELA for the purpose of ESSA. I want to make that clear because you may have growth scores that are associated with the K2 data or even with the interim assessments if you're giving those in grades 3 through 8, but those are not the growth scores that we use. We calculate a separate growth score using ACT Aspire achievement data. And we do that for grades 3 through 10 in math and English language arts. We also calculate growth scores for grades 4 through 10 students in science. We can't calculate the earlier grades, can't calculate grade 3 because we don't have any prior scores in science. Growth scores are also calculated for English language proficiency. So students who take the ELPA 21, English language proficiency exam, we also calculate using the same model, where have they been in their English language proficiency history, and what would we expect from them based on that, and did they meet or exceed or not meet what we expected of them. And that's done for grades 1 through 12 in English language proficiency. All right, what about students in grades 3 through 5 who don't have long score histories? This is something that's really critical, and this came from several years of modeling. The decision to do what I'm going to describe came from several years of modeling, stakeholder feedback about whether or not our growth scores were telling the stories that seemed to have the validity that folks were looking for. So all students' achievement scores are standardized. So we start by standardizing everybody's scores. Doesn't matter what grade level the ACT Aspire score is or what grade level the K2 assessment is. We transform their scores to Z-scores. So now they're on a standard scale where 0 is average and positive represents that the student is has an achievement score that's higher than average for their grade level. And negative numbers indicate that the student has lower than average achievement score compared to students in their grade level within Arkansas. That's really important. That's something our growth model is calculated for students in Arkansas. So we're not at an advantage or disadvantage based on a larger population across the country. This is about our students in Arkansas. By standardizing scores, we're able to include grades 1 and 2 scores in the score histories of students in grades 3 through 5. And this is important. This is really important. I'll show you examples speak louder than words. So let's take a look. What you're going to see in the coming slides. When available, the following scores are used for grades 3 through 5 score histories. So if I'm a 3rd grade student, as in the second column, I'm going to have a current year Aspire score, but I'm going to have a score history from grades 1 and 2 from their K2 test. And I'm talking about their actual achievement score, not a growth score. I'm talking about, for example, an NWEA, it's a RIT score. So that's what goes into the model. We transform it into a Z-score, and then we put it into the model. In grade 4, we're using grades 1 and grades 2 achievement scores from their K2 test. And then we're using the grade 3 Aspire, and then we're using their 4th grade score for their current year score. So now their achievement story is told from grade 1 through grade 3. And then 5th graders get the full history that's available from grades 1 through grade 4, their achievement story. And then we use their 5th grade current year score. This is a scale. If you're wondering what I meant about Z-scores, this is the simple formula that is used to calculate a Z-score for every student. So that Z-score is literally the difference between the mean, the average student, and the student that we're talking about in particular. Here's why this is so important. In our early modeling, we didn't really have score histories for grades 3, so we couldn't calculate a grade 3 growth score for students. And in grade 4, we were limited. If you look at, let's start with Robert at the bottom, who's a grade 3 student. There's no score history there. We don't know. We don't know what to expect in grade 3, so we don't calculate a growth score. And for Jan, who's a 4th grader, we only have 2 scores. And for Marley, we have 3 scores. But these scores don't tell all of Marley's achievement story. So we would have, if we were only basing Marley's 5th grade growth expectation on how Marley did in grades 3 and 4, we would have super high expectations. From grades 3 to 4, we'd be looking at the straight line. We expect Marley to knock it off the charts. However, Marley, and for Jan, we expect the same thing. We expect like that straight line. That line of best fit has very little information, and so we expect it to just extend. And then for Robert, we don't have anything. But let's add in their grades 1 and 2 stories. So in the chart on the right, we've transformed their scores now to a Z-score. And what we know about Marley is that Marley was above grade level in grades 3, 4, and 5. In grades 3 and 4 are very different. That steepness is very different from what we see when Marley was in grades 1 and 2. So if we built their expectation based on only grade 3 and 4, we would have a very high expected score, over 90 for sure. But if we build it based on grades 1, 2, 3, and 4, we have a very different expectation, and that's important. That's why achievement stories, their score history, are so important for estimating a more precise idea of where we expect students to be. So our model, we've really determined that 3 to 4 years are the sweet spot. If we go longer than that, then we have too much information, and you can actually lose some of your precision in estimating where we expect students to be. And if you have too short, then you have a less precise estimation. So then look at Jan. Once we put Jan's score history in on grades 1 and 2, it changes what our expectations are. So important, right? Because we want the full story. And this is what I think teachers in particular, having been a classroom teacher and knowing what I know about going back in time and seeing where kids have been and understanding what my challenge as a teacher is going to be, having that achievement story, having that score history was really critical, because I could see good and bad years for the student. And this model is sensitive to that, which makes it really incredible. So with Robert, now that we have information, we can actually see that probably by the next year, Robert's going to go from being below his peers in grades 1 and 2 and 3 to maybe probably, we're estimating that Robert will actually make up and be at or above the mean by the next year. So that's the importance of the way this model works at the student level. There's a couple of myths that are out there that I just want to address really quickly. First myth is that a student who is declining will be expected to decline. So remember I mentioned that the score history is super important because it tells the student's achievement story. And every single student's achievement story is accounted for in this model. So literally we call it random. It has random intercepts, which means we allow for every student's beginning point to be wherever it is. We don't have an expectation that they're going to be average. And then we also allow for the model to adjust for different score histories, which gives us the most precise estimate of growth. At the extremes, for students who are declining or scoring really low, or students who are exceeding, scoring really high, we have an effect that happens. There's a mathematical concept that happens in the model, regression to the mean. So if a student's declining, then the achievement of other students at the same grade level in the current year does help adjust slightly each student's expectation. So this student, if you look at these big X's, the student has a declining trajectory. And the concern we heard was, does that mean that the score in 9th grade, the expected score is going to be even lower? No, it doesn't. Because what happens is we expect that student to actually improve a little, because we're accounting for the fact that most students are, we're accounting for where the distribution of all students are a little bit, and it's adjusting slightly upward. The same is true at the really high end, because we do have kids who are way high, and there used to be this other growth model where you just couldn't demonstrate growth. Like students who were at the super high levels weren't expected to make any growth. That's not true in our model. Our model actually adjusts and has an expectation. Yes, the score history will set the expectation to continue to achieve at a high level. That's this. And the achievement of other students at the grade level in the current year helps to adjust the expectation when the student is further away from the rest of the population. So look at grade 6 and grade 7 here. Look at the box plot. That's the distribution of scores, the achievement scores for students. And the fact is that in this particular case, from grade 6 to grade 7, students in the state don't actually improve. The average actually drops a little bit. And so that actually helps to pull the expectation down. Plus the fact that this student is so far away from the average helps to pull the student's expectation down a little bit, which actually makes it a little bit more realistic. So those two myths you can put aside. And 2 more slides to kind of reinforce this. This is a slide that shows you what a typical elementary class might look like if we were comparing their 2019 growth score, which is on the vertical axis, and is on a scale where negative is less than expected, positive is more than expected, and 0 is what's expected. And then we were going to compare that to the year before, 2018, the achievement score. You can see here that you can have these low performing students who are growing more than expected. See them up here? You can also have low performing students who are growing at or less than expected. You can have high performing students who grow more than expected. You see these here. And you can have high performing students who grow less than expected. The same is true if we were looking at a typical secondary class where you have more students. You can see that it doesn't, the way that the model works is because we're using a student's score history, where they've been before, and it provides controls for these other factors that we were talking about that a school doesn't have control over. All students can have an expectation to grow. This is different from what you see on the ACT Aspire. I just want to spend a moment pointing this out. On the ACT Aspire, they give you these predicted paths, but they only consist of 1 year. And that doesn't use as much information. And so what they do is they tell you for every student, your student scored at a 400. So for every student who scored at a 400 in 9th grade, this is what they did in 10th grade. This is the range of scores. So this isn't estimating, this is saying this is based on what other kids have done who had the exact same score. Because we use a longer score history, we get a little more precision. So we're able to get a point rather than this giant cone. That's important. So I'm going to be running close on time. So let me move on to the English language progress to English language proficiency indicator. This is informed by stakeholders. This was something that we worked on very closely with the English Learner Advisory Team. And we use the exact same model. It is a multi-level residual gain growth model. It also accounts for a phenomenon that is true for English learners, and our data show it. That's what I'm going to share with you here, but so do the data of other states. So progress to English language proficiency in general, what we know from our data and just in general about English learners is that as their English language proficiency increases, their content scores also increase. So take a look at the graphic. Notice that the lower the ELP performance level, a 1 is emerging, a 2 is progressing, and 3 is proficient. EO stands for English only, or students who were never an English learner. Notice that the lower their proficiency level in English, the lower their content score in English language arts. So we need to account for this, and we need to not disadvantage schools that are serving these students with this model. So if you compare where our proficient students are with our English only students, they have pretty similar distributions. So we need to account for these kids' English language proficiency level when we're running our multi-level residual gain model in the content areas of English language arts, math, and science. So that's what we do. So notice this pattern occurs in all of the content areas. So English language arts, math, and science. The more proficient a student, an English learner is, the higher their scores tend to be, and the more similar they approach the scores of English only students who were never English language learners. So in fact, what we do because of this is we control for English language proficiency level of our ELs in the residual model. This is the only student level control that we use because of what our data show us. Each English learner's English language proficiency level on ELPA 21 is included in the value-added model for ELA and math and science to control for the student's language proficiency level. So they're put in as a 1, 2, or 3 based on their ELPA 21 score in the current year. And students, or their initial year, I think it's whenever they entered. And students who were never ELs are set to a proficient score of 3. So now we've really talked about everything there is to know, except the equation for the student level. And I think it's really important to understand the advantages our student level model has, because it is so advantageous to schools to have a model where at the student level, you're controlling for things that are beyond the control of the school. And what that means is that when you get a value-added score for a student, and then you get a value-added score for your school, you're getting different information from your achievement score. There are a lot of measures of progress that don't tell you anything different from what you could already say based on the achievement of students, but our model is different in Arkansas. Our model gives you different and better information from which to inform your work. And this is really important. This is probably the most important thing to remember, is that because of the way the model works and because of the way that we have built it based on the research literature and modeling Arkansas data and really understanding how the model is working, we know that it is an advantage to have a growth score in the ESSA school index at the school level, because it does give you different information than what your weighted achievement score gives you. So let's talk a little bit about how our student level scores are brought together and turned into a school level score. Each student is counted once in what we call the content value added score. VAS stands for value added score. If they have a math value added score only, then the student counts as 1 in the number of students, and their content value added score equals their math score. If they only have ELA, then their content value added score equals their ELA value added score. If a student, and this is usually the case, 99% of the time, students have both a math and an ELA value added score. And so those get averaged, and you can see the formula here at the bottom, the ELA value added score plus the math value added score divided by 2. Still, the student only counts as 1 student. So now we've gone from an ELA and a math value added score to a single content value added score. Again, we have other considerations for English learners, because when we did our research developing the ESSA school index, one of the things that the English learner group brought to our attention, which is, it's a well-known fact that across the state of Arkansas, you have some schools that have a very small number of English learners, and you have some schools that are predominantly English learners. And coming up with a system that treats this fairly is a real trick, but we did a great job here in Arkansas. And we have a group that's currently running some studies on a variety of states' models for English language indicators in ESSA. And we happen to have one of the best models for accounting for English learning and English learner proportions within our schools. So let's take a look at this. Every school will have an average content value added score. So each student's math or ELA value added score combined into a content is included in the school value added score. So we take the average of each student, content VAS, and we give the school their mean or average school value added content score. Then we also do the same thing for the English language proficiency value added score. So if you have English language learners in your school and they have a score history for the ELPA 21, then we are including their gross score run the same way. And we're calculating an average English language proficiency value added score in to the full score that goes in. So this is how our indicator works in Arkansas. So for English learners, there are actually 2 scores in the overall school value added score. An English learner will have a content value added score and an English language proficiency value added score. And this was intentional because the number of English learners who go into your value added score for English language proficiency enables the content score to be offset by that English language proficiency score. So remember when I told you that kids who are at lower levels of English language proficiency often have lower content scores. So if you're growing them in English language proficiency and your ELP value added score is higher, that's going to offset what is happening in content. So the theory of action is that as kids progress in their English language proficiency, they're going to do better in the content score. So if you're growing them in ELP, that's going to offset any detriment for a level 1 or level 2 learner in English language acquisition, because you're growing them in their proficiency, which in the theory of action, if you're growing them in their English language proficiency, then by the time they get to be proficient, they're going to be performing at as well as their peers who are never English learners. So in the end, our indicator for progress to English language proficiency is included in the school growth indicator in proportion to the number of English learners with growth scores. This is critical. Now, this is something that we actually had to get approval, special approval, we had to provide additional evidence to the US Department of Ed that this worked the way that we were proposing it to work. So let's recap, quick visual. A school gets an overall value-added score that goes right into the ESSA School Index. That is based on the average at the school level of students' content value-added score, plus the average of students' English language proficiency value-added scores. The degree to which the growth indicator is informed by growth on the English language proficiency is proportional to the number of students with ELP growth scores. Take a look at the formula. This is a weighted average. So if you see where in this formula at the bottom of the screen where it says number of English language proficiency students, if I have 5 students, then my English language growth score is weighted by that. That's important. And then my content is also weighted by the number of kids that I have a content score for. And then my denominator becomes the sum of the number of English language scores plus the number of scores for content. This is super important. This is what creates the proportional effect. Then our school value added scores, that final score that you saw on this prior screen, the school VAS, is transformed to fit into the ESSA School Index. 80 is used to represent 0, the average growth score. This comes from requesting from stakeholders or asking the question, if a school were to meet growth, if on average kids in the school were meeting growth, meeting their expected achievement, what kind of grade would you give them for that? And what we heard back from stakeholders ranged from 75 to 85. So from a C to a B. And so we split that difference and started with an 80. And so this was intended because there was a desire to put this on the same scale that all the other indicators are in the ESSA School Index. So we use 35, the number in this equation 35, this is the standard deviation to spread the scores. And then we take the school's value added score, which is on that Z-score scale, and we transform it so that it's on a scale that initially we wanted the spread to be from a 60 to a 95. The spread is a little less than that now. It's a little more compressed. And that's something that we've been studying over the years and watch. So school's mean value added growth score of 80 indicates that on average, students are meeting expected growth. And then if the school's value added score is above 80, then on average, kids are doing more than we expected, which is important, especially if your kids are coming to you lower achieving. The metric you want to pay attention to is the growth score, because you want to have a growth score that's above 80. And the further above 80 you can get it, and let me tell you, a score of 85 is amazing because of the standard deviation. Then that's how you're going to be improving the outcomes for your kids in terms of having it show up in achievement. If on average students are not achieving what we expect of them, that's going to either, if you're already high achieving, that could actually lower your achievement scores over time. If you're not high achieving, you're not going to make up ground because you're not growing your students. What's nice about our model is that it makes up for, it's in weighted achievements, you have to have more students at the different levels. And you can learn more about that in the indicator session that Public School Accountability is doing. But in our model, to get credit in the weighted achievement, kids have to be at higher and higher levels. But for growth, it's purely based on the history. So a student may not go from close to ready, but you still get credit if their score improved over what we expected based on their history. So these next few slides give examples of how, if this is an example of a school with a low proportion of ELs compared to the rest of the student body. So they have the number of ELs in the school is only 5% of the total N. And then content is the other, it's 95%. And so you can see if we use the formula that when we multiply the 13 kids by their growth score, which is higher than 80, it doesn't have as much of an impact as this score, which is multiplied by 239, because it's a lower proportion of ELs in the building. Now, the good news is for the ELs and for that school, Even though there's only 13 students, that's still boosting what their score would have been otherwise. So it raises a score from a 75.96 to a 76.31. And here you see one where it's almost the entire school is English learners. So here you've got this high performance, high growth, excuse me, not performance, but high growth. So English learners are really progressing in their English language acquisition. 65 kids, you can see that this actually ends up improving their growth score quite a bit to an 83 from an 82.09. That's a big lift. So that's what we mean by proportional. And here's two more examples. And let's talk very briefly, I've just got a few minutes. Let's talk very briefly about what's available to you. There are reports in My School Info, the ESSA School Index report. You can look at your specific data using your try-in login. We have the numbers broken down. So if you're interested in what your proportions are, here's the ELA value-added score, the math value-added score. When we average the score for these 166 students, this is what we get. Here's the content score. It's this number times, it's 166 times 85.13 plus 26 times 93.68 divided by 192, and that's what gives us 86.29. So you have all the numbers you need in your report to replicate the calculation if you need to do that. Now, if you want to see ends less than 10, you need to use your try-in login. But once it's made public, you can see also what you get to see are all of your subgroups broken down for your growth scores. So if you have numbers, this actually helps you to see the numbers of your students so that you can understand the proportion of kids that are contributing to a particular score. Now, growth is weighted in the ESSA School Index. The weights are assigned by grade span. So the K5 and 6-8 grade spans, it's 50% weight. And at the 9-12 grade span, it's 35% weight. If you are wondering where you are, the business rules available on the DESE website under informational documents detail the grade configurations and where they fit in these grade spans. You can go to myschoolinfo@arkansas.gov, use your try-in login, go to reports, ESSA School Index, value-added growth reports, and you can see all of the information about your growth score at the school level. You get scatter plots that help you understand your weighted achievement score versus your growth score. This particular school example has really high growth compared to other schools that are in the same grade span, which is really, this is the place you want to be. If you're not up here, then you want to be in higher growth. This other quadrant down here, lower achievement, higher growth. These are the less desirable quadrants over here because your students aren't growing as expected on average. And then you can see it broken down by subgroup. You get 3 years by subgroup and you get the values. So a lot of information available to you. Let me address this final caveat. 2021, we will calculate skip year growth. We modeled skipping a year of growth back in May of 2020. We modeled it by using 2019 with 2018 as the missing score so that it would look, so we could see what it might look like when we do 2021 with a missing 2020 score. Since we did that modeling over the course of time, a bunch of publications have come out that have supported the use of these scores. What we learned from our modeling is that the results are pretty close. There's a little more variance or noise or in the scores in the result, but not so much that you would be concerned about using them for the kinds of reasons we're talking about using them. Accountability scores, the ESSA School Index scores this year are going to be used for information, for informing where are we after this crazy pandemic. They're not going to be used to assign letter grades. That was paused in the last legislative session. So the stakes are lower. The information you're going to get is intended to inform you about where your kids are. And this information is critically important. This information will help you to understand what happened. We'll be using, this is a table that shows you that we'll be using all scores that are available from 2016 through 2019 to estimate where we expect students to be in 2021. And that's how we're going to run the model. This is called skip year growth. And the important thing about skip year growth is that it does provide for you a way to understand how students have fared growth-wise, you're going to get achievement levels on your students, and that's going to tell you where they are relative to the close, ready, and exceeding cut. But what the growth score is going to tell you is a little more nuanced, because they may have been close or in need of support. They may not have shifted categories or levels, but they may have still grown in the time that you've had them this year, or they may have lost ground. So this growth score is going to be critical to helping you understand how your students are doing at this more nuanced level of measurement in terms of their growth and achievement. Again, how did that line look as opposed to that point? And based on what we learn about on average, where those lines are for our school, that's going to help us at the school level and at the district level to allocate resources, to understand what we need to do for support, to utilize our American Rescue Plan money, which is going to be a phenomenal amount of money, and to deal with our unfinished learning due to the pandemic. This is a critical point that the reason we're going to go ahead and do this and give you guys this information is so that it can give you some of this nuanced information that you won't learn necessarily from when you just get achievement results back. And so I just encourage you to use this only for those low stakes and for those support types of decisions. It's not intended to be used in a high stakes way to punish kids, to place kids, etc. It's to help you understand what their achievement story has looked like during this pandemic and what work lies ahead. And so I encourage you to use it in that way. And that takes me to my last slide, which is basically, if you have questions, I'm really hopeful that we've answered a lot of your questions. If you're concerned and want to know more about school reporting, there's going to be a session on public reporting. There's going to be a session on the various indicators that are used in the ESSA School Index. I encourage you to look in the schedule and figure out where those are and attend those if that's your area that you're really interested in. If you have general questions about the growth models use in ESSA, then you can email Tiffany Grayer or Louis Farron. If you have technical questions or there's just like something that's nagging at you technically about this, then give me an email. I will tell you it's going to be a busy summer. We're going to be running all of this and then evaluating all of this before it gets put out. We're going to run it through our technical advisory committee, which is the TAC. We're going to be really, really busy, and I promise I'll do my best to get back to you as I can if you email me. That's why I'm giving you the first line of Tiffany and Louis, so that if in fact they can't answer your question, then they can forward it to me. So I appreciate your attendance in this session. I hope that this has answered your questions, and I look forward to being able to provide this information and help you to understand it as we move forward. Thank you so much. And I wish you a great rest of the summit. Thank you.